All right, so we did some simple probability, and so I want to review that before we jump into this new topic of compound probability. So, the idea of simple probability is just what is the chance that one event is going to happen? Okay, so if I have four blue socks, I'm making up this problem here, three green socks, and seven red socks. What is the probability that tomorrow morning I'm going to walk in, grab a sock, and it's going to be red? So we'll say the probability of red. That's what that's asking. So the two things you're going to need to know is, first of all, how many red socks do we have? What is the possibility? Like what number of red socks? And then how many total socks do we have? And so we take a look at that and we say, okay, I've got 4 and 3, that's 7, and 7, that's 14. So I've got 14 total socks. And out of that 14, seven of them are red. So that means that 7 out of 14, if I did this over multiple times and really truly randomly mixed up my socks, 7 out of 14 times I would get a red sock. Now we can reduce that and it would be 1/2. That means that 50% of the, well, we can make that into a percentage. 50% of the time, I'm going to get a red sock. Okay. And so that is the idea of compound probability. Okay, hold on. I've got a dog here. All right. So 50% of the time. So that's the idea, sorry, of simple probability. So this is a simple probability problem. So one day I'm bored and I really want to know, well, what if probability? What is the chance of me pulling that red sock out and then immediately pulling out a green sock? And so there's all these different ways that we can find these more complicated probabilities. And in this case, it's compound probability. Okay, and so there's two types of probability that of the compound nature. So it's really asking what is the probability of two events happening? And how we calculate that is going to depend on what happens right here. If I choose my red sock, I have two options. Am I going to return the sock after that first pick and then draw another one? Or am I going to keep the sock out? And that changes the probability of that second draw. The probability of the red and green, if I return it in between, is going to be different than the probability of the red and green if I keep it out. And so really pay attention to that here as we're going through this. I'm going to emphasize that every single time. Okay. A couple things I'm going to say. How many do we have? How many lollipops do we have? That's the first question I'm going to ask every time after I read the whole thing. The second question I'm going to have is, what do we do in between? Do we put it back? That is the next question. Okay. And the answer to that will then determine that probability. Now, when we have, let's just talk about flipping a coin. And so I'm just going to talk about a very simple probability. What is the probability of heads? Oh, that's 1/2, right? So just to show you how this works when I have two different events, what is the probability of flipping heads and then flipping heads? And the replacement isn't an issue with this because coins don't have replacement. Coins just always have two choices, right? And so the heads would be 1/2, and the second time the heads would be. So the first flip, the probability is 1/2. The second flip, the probability is 1/2. The probability of getting heads and then heads would simply be taking those two probabilities and multiplying them. So it would be 1/4. Okay, so I'm going to flip the coin twice. What is the probability of getting heads and heads? It's going to be each individual probability multiplied. Okay, very simple. Heads is tail. Try that one more time. Coins are very simple because they have two options, and you don't have to worry about replacement. Okay, but when we get to this, once we figure out the probability of each individual event, we're going to multiply them. All right, so here is our first problem. A bag has 6 orange lollipops, 5 green lollipops, 3 blue lollipops, and 7 speckled lollipops. You randomly pull out a lollipop from the bag. You put it back and then pull out another one. What is the probability of getting a blue? So I'm going to go ahead and write this down. Of getting a blue and then a green. Now I'm going to just write these as two separate things because the probability of getting a blue and then the probability of getting a green is going to be multiplied. Okay, now in this case, it's going to be put back. So the first question I ask is, how many do we have? 7 and 3 is 10, 15, 21. We have 21 lollipops. The probability of drawing a blue lollipop. Okay, so there's 21 choices. Of those 21 choices, 3 of them are blue. So it's going to be 3/21. So now this is where it gets a little bit dicey. This is when we have to ask ourselves, did we put it back? If we put it back, then we still have 21 lollipops. Okay, so in this case, that doesn't change. And then a green. How many green are there? 5. 5 green. So 5. And so in this particular case, it was a little bit simpler. The put it back scenario is much simpler. It's the two individual probabilities multiplied. So then we're going to, and I recommend saying, okay, let's reduce this. So 3 goes into 21 7 times, so 1/7. You can use the Desmos for this. If you use the Desmos for this, then you can multiply those fractions. 1 times 5 is 5. 7 for 147, and then that is going to be the probability right there. Okay, so that one's, like I said, that's of the put it back nature. So let's go ahead and keep going with this and see where the different ones take us here. Okay, so you randomly draw twice from this deck of cards. What is the probability of drawing an H and then drawing a C? And we're going to multiply that. I'm going to highlight this without replacing the first card. Without replacement. So this is different. The other one did replace it. This one's not going to. All right, so the same question that I asked first time around. How many cards do we have? Oh, 6. So I'm going to go ahead and put 6 here. What is the probability of drawing an H? Well, I look up at the cards and there is only one H. So it's going to be 1 out of 6. Now, in this case, I draw that H and I don't put it back. So I'm going to cross it out. Kind of helps to visualize that. So when I go to see what the probability now of drawing a C is, I look and see I don't have 6 cards anymore. I only have 5 because I took one out and didn't put it back. And out of that 5, 2 of them are C's. And so I'm simply writing the two fractions. 1 times 2 is 2. 6 times 5 is 30. I can reduce that. It's going to be 1/15. And that is the probability of drawing an H and then a C without replacing it. Okay, and so the biggest difference here on these without replacing ones is right here. The first draw we had 6. Because we didn't replace it, the second draw we only have 5. All right, let's take a look at this next one. And looks just very similar, but the thing is, it could change even just based on whether or not we're replacing it. Okay, so what you randomly draw twice from this deck of cards. I automatically start observing some things. There's 6 of them. What is the probability of drawing a C and then drawing a B, and then I highlight this, replacing the first card? So this changes. This is not like this one I just did. This is not that one, because that one didn't replace it. This is, okay? So let's look and see how that's going to affect things. We do have 6 cards, so I'm going to go ahead and write 6. I'm going to draw a C. There's only 1. Then times. Now, I replaced a card. So I took that C out, but I put it back in. So when I go to draw a B, I still have draw for a B, to try for a B. I still have 6 cards. And just like the C, I only see 1 B there. 1 times, so then I just multiply. 1 times 1 is 1. 6 times 6 is 36. The probability from that deck of cards of drawing a C and then a B is 1/36. And if I actually kind of multiplied that out, or divided that, 1 divided by 36 is basically 0.027. This is not part of, put this in and get more math, but just get an idea. So if I move the decimal 2 places, it's basically 2.8%. So that's like about 3 times out of 100 that would happen. So just so you kind of get an idea of, well, what does that actually mean? It actually means that that it's about 3%. So it's very unlikely that you're going to do that. I mean, you could do it, but it's very unlikely. Okay, so let's go ahead and keep moving on. That part is not necessary. You probably will be doing the just doing the fractions. Okay, so we have one of these here. A bag has 2 speckled lollipops, 3 white lollipops, 3 blue lollipops, 6 yellow lollipops, and 4 black lollipops. You randomly pull a lollipop from the bag. Keep it out. And then pull another one. What is the probability of getting a yellow and then a blue? All right, so the first question I always ask is, how many lollipops are there? How many are there? So I've got 2 and 3 is 5, 8, 14, 18. Sometimes I like to go backwards. I'm going to say 18 here. 4 and 6 is 10, and 6 is 16, 17, 18. Okay, 18. Sometimes I'll count it forward and then backwards just to double check myself. So the first draw, there's 18 lollipops, and the question is, what is the probability of getting a yellow one? So over here, I see in the yellow, well, there's 6 of them. So it's going to be 6 out of, hold on a sec, 18. All right, now at this point, you have to look at this. We keep that one out. So we had 6 yellow lollipops. Now we only have 5. Not only that, we had 18 lollipops. Now we only have 17. And then you're trying to pick a blue. So then you look and say, oh, there's 3 blue. So I'm going to put that there. Okay. And so, oh, look, I can reduce this. And reduce as much as possible. So this is going to reduce and be 1/3. Okay. So now I go to multiply. You could use the decimals to multiply it before, whatever. 1 times 3 is 3. 3 times 17 is 51. And that's it. Okay. And so you're kind of getting hopefully getting the hang of it. first, how many are there? Second of all, and that helps us determine the first probability. Whether or not it is replaced or kept out helps us determine the second one. So let's take another one. The bag has 2 red scraps, 3 blue, 7 speckled, 2 yellow. Randomly pull. What is the probability of getting a yellow and then a blue? And I'm looking for a specific type of problem. This isn't it. Well, I might have to jump ahead a little bit. So 2, 5, 12, 13, 14, 9, 10, 11, 12, 13, 14. So there's 14 scraps. Okay. So in the first one, that's easy, 14. How many of those are yellow? 2. So that's going to be 2 out of 14. So I haven't even looked at this yet. Keep it out. Oh, see, that's going to be important. So if I pull that one of those yellow scraps, now there's only one left, but there's also only 13 scraps left. So when it's kept out, we have to reduce that one by 1. And there's 3 blue scraps in the bag, so I have a probability of 3 there, so 3 out of 13. I'm going to reduce this. This is 1/7. 1 times 3, it's 2191. So 3 and 91. I'm doing all the math in my head, so if you see that I make a mistake, like double check it with a calculator. Okay, so, but I'm doing it pretty quick. All right, you randomly draw twice from this deck of cards. So I see, okay, there's 6 cards. Okay, so that's good. What is the probability of drawing a C and then drawing a D, replacing the first card? Okay. So we're replacing it. Okay, I like that. So there's 6 cards. So the probability of, oh wow, there's 1, 2, 3 C's. So the probability of drawing a C is 3 out of 6. But we put it back. So we drew it out, but we put it back. So we don't need to cross it out. So that means for the next draw, when we're looking for that D, there's still 6 cards in there. And there's only one option, one possibility of a D. Okay, I can reduce this. This is 1/2. 1 times 1 is 1. 2 times 6 is 12. So that's actually a pretty good possibility. 1 out of every 12 times. That's a pretty good, compared to 3 out of every 91 times on the previous scenario. You know, that's pretty good. All right, so hopefully you're getting this idea. There is one type, replacing. So I want to, blue and orange, replacing, blue and red. So I've got some other ones. There's one scenario that I might have to make. There we go. All right, so let's look at this problem here. A bag has, so this one here. So a bag has 7 red rocks, 3 blue rocks, 7 yellow rocks. You randomly pull a rock from the bag, keep it out, and then pull out another one. What is the probability of getting a red and then a red? What makes this one different, number 1, is that we're not putting it back. And number 2, it's the same color. That's different than all the other ones because it was the first pick and the second pick were different colors. So I wanted to make sure I go over one like this. And I'll go over a couple more here so you kind of see because it changes a little bit. All right. So this is keeping it out. This is without replacement. All right. So first question, how many are there? 7 and 3 is 10 and 7 is 17. Yeah. Okay. So there's 17. So the first one, there's 17 possible rocks, and 7 of them are red. So 7 out of 17 is going to be that first probability. Now, here's the deal. You're taking it out, and you're not putting it back. So that means that I had 7 rocks. I took one out, and I now have 6. And you saw me write that on some of the previous ones, but on the previous ones, it didn't really matter. You probably didn't even notice it. But this time it does, because this time I had 17, but when I go to draw another red now, I took a rock out and didn't put it back. So now I only have 16. Not only that, but it's the same color. So last time I went to draw a red one, there were 7 red rocks out of the 17. This time, because I already drew one out, there's 6 out of 16. And so really, and this particular case, because they're both the same color, actually the top number and the bottom number reduced by 1. And so that's a little bit different, that comparative to the other ones. And so, if you look up, so at the yellow and blue one here, we kept it out, but you notice that whatever number, so this was blue was 3, and that's the number I used. I didn't have to reduce that number. Okay. All right, I think you got the point. So I'm going to go and find my example here. All right, so then now it's left to the same thing that we've been doing. So I'm going to reduce, so that's divide by 2. This is kind of a big number. 7 times 3 is 21. 56, 136. And like I said, check my math. I'm doing this all in my head. So, but that would be your fraction there. So that means that 21 times out of 136 draws, theoretically, we would draw both a red and a red. Okay. All right, so you see that difference. So let's go ahead. I'm just going to do another one of these. So you can dive out at any time and go to Get More Math and do these problems and then come back if you get stuck. Okay. But I've got 2 more that I'm going to do here, 6 and 7. So in this case, I've got cards. I'm pulling them out. I've got 1, 2, 3, 4, 5, 6, 7 cards. So 7 cards. Okay, that's kind of important. So what is the probability of drawing a 3? I'm glad I did this one. And then drawing an even number. So that kind of is a new scenario as well. Replacing the first card. So we do have replacement. All right. So we have all of these cards. We have a total of 7. So I'm going to put that 7 there. How many of them are 3? Okay, there's 1. There's only 1 3. So we draw that 3, we put it back, and now we're going to draw another card. What is the probability of it being even? Well, I still have 7 cards because I put it back. So now I have to look. What are the even numbers? This one, and this one. Did I miss any? No. So that's 3 even numbers out of 7. Okay. And then 1 times 3 is 3. 7 times 7 is 49. Voila. Okay. So last one, the bag has 1 marble, 1 red marble, 2 green marbles, 4 speckled marbles, and 5 white marbles. Okay. You randomly pull a marble from the bag, put it back. Okay, put it back. What is the probability of getting a speckled and then a speckled? Okay, we put it back. Okay, so we want to pay attention to that. So, all right, so first, how many do we have? Count it up. 1, that's 3, that's 7, that's 12. So 9, yeah, that's 12. Okay, so we have 12 marbles. How many are speckled? 4. 4 speckled. Okay, so then the next one, we put it back. So we take out that speckled marble, but we put it back. So the probability on this next one should be the same because it's 4 speckled marbles out of 12. And that's comparative to this one up here where we kept it out. So there we go. So we kept it out. That changed that second one. The red and the red, it was the same type, and it changed the second one. But on this one, because we put it back, this ends up being the same. It matches that one. So you don't even have to go back and look at it. You just know, okay, speckled. We had replacement, so they're going to be the same. I'm looking at reducing here. 4/12 is 1/3. 4/12 is 1/3. So basically we have 1/3 times 1/3, which is 1/9. Okay, and so that's all I'm going to do there. I'm going to post this. Please let me know if you have any questions and pop back and forth. Try to do some of your problems and then come back and look and see if there's one that fit yours better, and then pop back over. So just kind of go back and forth as needed. All right, good luck.